Hello, my name is Saurav Biswas. I am a data architect with DataStax. Today, we're going to do a short demonstration which will show you how to use Workpools with DSE Analytics. At the same time, we'll also make sure that we understand the ownership of the folders and files that are created when you run a Spark application on DSE Analytics. In this video, we'll cover a few things. We'll give you an overview of how we have set up our cluster. Then we'll tell you how to set up workpools and show you how you can restrict permission to those workpools using DSE authentication and authorization. We'll give you an overview of the sample Java code that will simulate folder creation. We'll execute the code and we'll verify the ownership of the folders that were created by the driver as well as the executors while they ran the application. And finally, we're going to demonstrate how workpools can restrict usage of Spark resources, even when your users might try to run their jobs with a higher resource than that's what's allocated for them in their workpool. So let's go ahead and start a demonstration. Let's take a look at the cluster I've set up for this particular demo. I've used EC2 instances. It's all on Amazon Cloud. There are 3 nodes, and all the nodes have search as well as analytics workloads enabled on them. I'm going to use the EC2 ring utility to take a look at the server health, the cluster health, as well as the workloads, their topology, the rack and DC. So you see there are like 3 nodes all on the same rack, on the same DC. All of them have search and analytics enabled. I've used a very simple setup just to demonstrate a particular use case that we're going to target. So you can see like the Spark master is running on the node with IP ending in 244. This is the private IP. And the corresponding public IP is 102. And on port 7080 of that particular IP, we have the Spark master UI running, which gives you an overview of the Spark cluster. In this cluster, you will see, as expected, there are 3 workers running. The total number of cores that my Spark cluster has is 33, and the total memory is close to 160 gigabytes. One interesting thing to note here is under the cores or the memory, essentially the resources of your Spark cluster, you will see there are 3 categories. One is default, one is high, one is low. High resources, low resources. Similarly for memory. I will briefly explain where these particular subcategories are coming from. These are essentially the workpools. If you look at the jobs that we have run, we assign a workpool to all our Spark submissions. When you submit a driver, you mention a workpool, and that workpool is also associated with the user, the DSE user, who is submitting this particular job. What that ensures is, if I'm a tenant who has certain resources allocated to me, I can under no circumstances submit a job that consumes more resources. So I can always go ahead and try to give a total number of cores that's higher than my low resource allocation of 3 cores, right? Workpool and the whole setup of Workpool ensures that you're never able to do that. Let me show you how you set it up. And then while demonstrating the actual application or actual process, we will show you how, if you try to use something that you're not supposed to, like a workpool that you're not supposed to, you will not be allowed to submit your jobs. Going back to that particular node we were in, let's take a look at the DSE.val. I have package installation, so my default location is DSE YML. For tarball, you can go to that particular tarball location of configurations. Now out here, if you search for Workpool, you will see it's a subcategory under resource manager options. Resource manager options essentially controls how much resources are allocated to your workers. And out here, what I've defined is the high resource and the low resource. Now, if you remember, you did not see always on SQL in the Spark Master UI, right? Because this is reserved for your always on server. If you're not using that feature, you can always go ahead and remove some cores and memories from here. The high and the low resources are what we have defined, and it can be number of workpools. You can have multiple workpools. Whatever is left from these, so 1 minus the sum of cores in each workpool goes to the default workpool. So the default workpool is used when no other workpools are being used, and you can actually ensure that your resources or your users can only use a particular workpool. And we'll see how to grant those permissions. It's all documented, but let me show you how it looks like. So let me go to the SQL shell. I'm going to do the worst practice of typing in the password on the screen, but since it's just a demo environment, I'm doing it. So let me take a look at a user I have created, right? So list all permissions of, right? So this is a role I had created. And if you look at it, you will see it has different permissions and stuff. But the most important aspect of it is the first row in the roles, where you see it has create permission on the low resources workpool in enterprise data center. So as long as they are using the low resource as the workpool, they can create submissions, or they can successfully create applications and drivers in your Spark cluster. If they do not have access, they want to use workpool 3, supposedly they wouldn't be allowed to do it. They'll encounter an error when they try to do it. So this is a very good way of tenant resource control. If you have a multi-tenant system, as operations team, you can address the concern of overutilization of resources by a particular team. You can totally restrict them to some resources. Very useful tool. That's why we wanted to demonstrate this feature also as part of that. Next, I wanted to show you what my sample Spark application looks like. I've created a very simple class. All it does is create a folder from the driver and then create folders from each of the executors or workers. So how have I achieved it, right? So if you see, this is the main class that's going to be provided as the main class for the Spark Submit job. Here I'm creating a simple directory and I'm appending the directory name with driver underscore sample. Everything is going to be created in the temp folder. I'm using the local file system, but the behavior would be same when you're using the NFS file system like you do. Important thing to note here is I want to figure out which operating system user is becoming the owner of that particular file, right? So suppose I launch my Spark job or issue my Spark submit as operation system user 1. Do these folders get created as OS1 as the owner, or are they created under the OS user that runs the Spark process, which by default is the DSE runner process, which is Cassandra user. Though of course there's this whole concept of slot users, and we're not going to discuss slot users. We're just assuming we're using the default Cassandra user for running all Spark applications. So that is one aspect of it. Our understanding or expectation is the owner after the full descriptor should be Cassandra user. Similarly, to make sure that the workers are also writing the executors or the workers are writing or creating folders as part of the tasks, right? I've created a sample code here where it's doing the same thing, but the folder is appended with executor underscore sample. And even at the end of it, again, I'm going to print the owner as well as going to check the folders using a list command and make sure that our expectation matches with what is being done, what is being actually produced on the servers. And that expectation being both of them should be owned by the Cassandra. All right, now I'm back to the node and I'm going to try to do a Spark submit and see what happens. Before I start, let's do one more task, right? Let's make sure just on one node that I have no driver underscore sample or executor underscore sample folder. I made sure that I have removed it from all the nodes just for a fresh demo, but as you can see, it's not there, right? So it's not going to be an issue. I can also do this, right? Let's do this thing. What I'm going to do is use a utility to do a ls on all the nodes on my cluster. So it's like a parallel SSH tool, and I'm going to use it to make sure that the 3 nodes that I am on, right, doesn't have any folder that starts with driver underscore sample or execute underscore sample. Just making sure it's clean so that we have fresh test results when you run it. Now let's try to run a Spark submit. I've used DSEFS to put the jar file that I've compiled out of the class that I showed you earlier. And the reason for using DSEFS is it's always the best practice to have a shared location where you put your jar files or executables. It can be an NFS mount too. You can also use your local, but just have to make sure that your jar is present in all the local nodes. And it's not always pretty when we do that because you can run into version mismatch, stuff like that. So let's assume that you'll always be using a centralized location which is accessible from all the nodes. In our case, it's DSEFS. So let's go into the DSEFS system and show you where I'm putting my jar, or where I've already put my jar. So what I'm going to do is execute ls command on DSEFS, and if you see there's a jar called write read 01 all.jar. I'm going to use it in my Spark submit. So I'm going to go back and use one of the Spark submit commands I already used in the past. So if we really look at it, right, what all parameters I'm passing to it? I'm passing the jar name, which is in DSEFS, right? So this is the jar name. Then I'm passing the main class, which I showed you, right? I'm passing the master URL. And the reason for passing the master URL is this is how I can make sure I mention the workpools. I'm mentioning low resource workpool for my master URL. That indicates this Spark submit should submit the job using low resource workpool. Then you have the deployment cluster. Obviously, we always use the cluster mode for all production deployments. And I have to pass a DS user who will help with submission of the job, right? So inside the code, the DS user has to have access to your key spaces and your data, but this particular user you're going to pass should have the bare minimum permissions which are listed up there, if you see, to be able to submit a job to a particular workpool, right? So let's try to run it and see what happens. All right, so we see that the driver has been created. This is the work on which the driver is running, and this is the ID of the driver. Let's go to our Spark master and see what it looks like. So you see the driver ending in 0011 is running. The application ID is running. Let's go into this driver worker, right, and see the driver is still running. And if you remember, I was printing the folder and its permissions, right? So here we are. We see it says that we have created this folder on this particular worker node, and then the owner is Cassandra. Another important part I want to show you when I go back to the code is at the very beginning, I'm printing the operating system user who is executing this piece of code. And that is to figure out how or who owns the process that is being spun off by the DSE Spark submit. Is it the user who is actually issuing the DSE Spark submit, or is it a default Cassandra user who is running all the Spark processes? So this particular log statement makes sure or confirms our understanding that Cassandra, or the default Spark user, should be running this code and not automaton user who is actually issuing the command, right? So that part is confirmed. Now let's go back to the master, right? And let's look at the application that was spun off as part of this whole job, right? The job we submitted. If you look at the two workers that were involved, right? So if we really go to the worker std out, we should be able to see those statements that were being printed out by the executor code. So as expected, again, you see there are these temp hyphen executor sample folder being created. This folder is being again owned by the Cassandra user. So once again, as expected, the Cassandra user is creating or running that piece of code. So that being said, we confirmed a few things, right? We confirmed that doesn't matter who is issuing the DSE Spark submit command, your code is going to be executed as a Spark user. If you had used slot users, maybe you have got slot users as the owners, but we're again not going to the discussion of slot users. We are going to stick to the default Cassandra user. And how do I make sure? Just to make sure that whatever is getting printed is actually what's happening, I'm going to issue again that parallel SSH command to look at the actual LSLA output from this temp folder. And if you see, we have the driver sample that has been created here owned by Cassandra, the executor sample owned by Cassandra. There are two executor samples owned by Cassandra. So two partitions were executed here, one partition was executed in this worker, but essentially proves our point. Let's take a look at another use case. For example, you're using a correct workpool. Right, so you're a low resource user, you're using the low resource, but what if you're trying to bypass the system and pass extra number of cores, right? So total executed cores is 10, although I'm allowed a max of 3 as per my configuration. Let's see. Okay, so now all 3 cores are available. So what happens if I execute something like this? The driver, I'm expecting, will get running and submitted and accepted because, of course, it's well under It will require just one core. What happens to the application that the driver spawns? It has got 2 cores and it's running, right? Let me try to run it again while the original one is also running. Again, the driver is in a state of running, and if I go there, you see it's running, but no matter what we have passed as a parameter, the total number of cores that are assigned to your application plus the driver core always results in the maximum number of cores that your low resource work pool attains. So even if you try to bypass the system, it won't let you. In this demonstration, we have used DataStax Enterprise Edition 6.7.7. Please note that this is not our official DataStax direction, but a knowledge share that may go stale as a result of new releases. Make sure to check the current documentation of the version you're going to use. Thanks for your time, and hopefully this content was helpful. For more information, you can always go to datastax.com/dev and find excellent articles on different subject matters.